In our world, things bend, they flow, they heat up. And yeah, sometimes they break. But what if you could see all of that happen before it's even real? Today, we're diving into the incredible power of engineering simulation through a tool that does exactly that. We're talking designing safer cars, life-saving medical devices, the whole shebang. It's called ADINA, and it's about to show us how you can literally simulate the future.
So let's start with a question that's a classic engineering nightmare. I mean, think about it. You're responsible for this massive bridge, but how do you know it'll survive an earthquake that hasn't even happened? How do you see those invisible stresses, predict the breaking points, and test for a future you can't control? Well, the answer isn't to build it and just cross your fingers. No way. It's to build a perfect digital copy first, a digital twin. All right, so here's our game plan for this explainer. First, we'll look at the massive puzzles engineers are up against every single day. Then, we'll introduce the powerful digital tool they use to solve them. We'll dive into what gives ADINA its superpowers, then see how it's actually changing the real world. And finally, we'll talk about why the future of engineering is, well, being built inside a computer.
Okay, so when you boil it all down, engineering is really about one thing: prediction. You have to be absolutely certain that the thing you've designed on your screen is going to work and work safely out there in the messy, completely unpredictable real world. And that real world is just full of these complex, interacting forces. I mean, it's not just about an object sitting there looking pretty. It's about how it responds to everything happening to it and around it, all at the same time. Things like vibration. Just picture an airplane wing slicing through the air, or a skyscraper swaying in the wind. Every single structure, big or small, is constantly vibrating. And believe me, those tiny little movements can lead to huge problems if you don't plan for them. And then there's heat. You've got everything from a blazing hot engine block to the super subtle thermal expansion in a bridge on a summer day. Temperature changes everything. It affects a material's strength, its shape, its entire lifespan. And of course, you can't forget the power of fluid flow. Whether it's the air rushing over a race car to stick it to the track, or water surging through a massive dam, trying to simulate how liquids and gases move is a giant piece of the puzzle for so many designs.
So, how on earth do engineers tackle all this mind-bending complexity? I mean, they can't just build 1,000 different prototypes, right? Instead, they turn to this brilliant method called Finite Element Analysis, or as you'll usually hear it, FEA.
The best way to think about FEA is like building with digital Legos. It takes a really complex object, like that bridge we were talking about, and it breaks it down into thousands, sometimes millions, of simple, manageable little pieces called elements. A computer can easily calculate the forces on each individual piece. Then, and this is the magic part, by adding up the behavior of all those tiny pieces, it builds this stunningly accurate picture of how the entire thing is going to behave.
Now, in this world of FEA, there are a lot of different tools, but some of them are true heavyweights. And one of the most respected is ADINA. I mean, the name alone, Automatic Dynamic Incremental Nonlinear Analysis, that kind of tells you it's built for the really tough stuff, the super complex problems that make other programs just give up.
So what gives ADINA its edge? What are these superpowers that make top-tier engineers turn to it for their most critical projects? Well, it really boils down to a few key things. It all comes down to these 4 areas. It's a master of something called nonlinear analysis, which is absolutely essential for modeling reality. It can handle the complex stance between fluids and solid structures. It's famous for its high accuracy, and it can even juggle multiple types of physics at the same time. Let's really dig into a couple of the most important ones.
Okay, let's start with this simple idea. A linear behavior is predictable, right? You pull on a spring, it stretches in a nice, neat, proportional way. Easy peasy. But the real world is messy. It's non-linear. Think about a car crash. The metal doesn't just bend, it crumples, it tears, it deforms permanently. That chaos, that's a non-linear event. And accurately simulating that is where ADINA truly shines, because the math gets exponentially harder when things stop behaving in a straight line. Another superpower is something called fluid structure interaction, or FSI. This is where things get really, really interesting. It's what happens when a fluid, like air or water or even blood, pushes on a solid structure, and that structure's movement then changes how the fluid flows. It's this constant feedback loop. You can imagine an aircraft wing vibrating in the wind, or something even crazier, like modeling blood flowing through a flexible artery. And listen, This isn't just some theoretical code on a screen. These capabilities have profound real-world impacts across a massive range of industries. This is where all that simulation becomes reality.
I mean, just look at the sheer breadth of this. For civil engineers, it's all about analyzing the stress on a bridge to make sure people are safe. In the biomedical world, it's about making sure a new hip implant is going to work perfectly inside the human body. For aerospace, it's optimizing a wing for maximum fuel efficiency. The tool is the same, but the applications are just incredibly diverse.
Let's go back to that car crash example. Before a single piece of metal ever gets stamped, engineers are using ADINA to run hundreds of virtual crash tests. They can see exactly how the car's frame is going to crumple and how it's going to absorb energy to protect the people inside. So let's be clear, this software directly helps save lives. Or how about this? When doctors are developing a new stent to open up a blocked artery, they can use ADINA to simulate exactly how that device will interact with blood flow and the artery wall. This helps them design better, more effective medical devices that can improve or even save a patient's life. It's just incredible. So what all of this really points to is a fundamental shift in how we design and build the world around us. Simulation isn't just a step in the process anymore. For a lot of projects, it is the process. And this right here, this gets to the very heart of the revolution. In the old days, engineering meant building these incredibly expensive, time-consuming physical prototypes. You could only test a handful of scenarios. It was all about testing what is. Now, with tools like ADINA, engineers can run thousands of simulations on the cheap and super quickly. They can explore endless possibilities, and most importantly, they can predict what if. And that's why, when it really comes down to tackling our biggest challenges, ADINA has become the #1 ally for so many engineers. From creating sustainable energy, to building safer infrastructure, to advancing medicine, it's that indispensable tool for turning these complex ideas into reliable, real-world solutions. So ultimately, this technology is almost like a crystal ball. It's a way to test and refine and perfect our greatest designs before they even exist, to literally see a version of the future. The only question left is, what amazing things are we going to choose to build with that power?